Deep in the high desert basin of northeastern Utah lies a 512-acre parcel of land that has baffled military scientists, intelligence officers, and independent researchers for decades. Skinwalker Ranch is legendary, not merely for its history of unexplained aerial phenomena or indigenous folklore, but for the physical, measurable anomalies that defy standard scientific classification. For years, investigation teams focused their sensors on the sky, tracking unidentified objects that appeared to materialize and vanish directly above a prominent geological feature known as the Mesa. However, recent subterranean exploration efforts shifted attention away from the atmosphere and straight into the solid sandstone structure itself. What began as routine geological core sampling quickly evolved into a high-stakes scientific recovery operation when deep penetrating sensors hit an impassable underground void. Subsequent radar sweeps and drilling attempts revealed that beneath millions of tons of fallen rock, the mesa does not consist entirely of natural earth. Embedded inside is a deliberate, highly engineered chamber, a subterranean tunnel system that appears to have been sealed shut for decades, if not longer. The story of how researchers finally reached this subsurface anomaly begins with ground-penetrating radar scans. During systematic surveys across the top plateau of the mesa, geophysicists detected an unnatural reflection profile, a flat, highly defined horizontal plane situated roughly 80 feet below the rock surface. In natural sandstone formations, radar signals scatter randomly through fractured strata and moisture pockets. But over a specific 200-foot stretch of the mesa, the radar signals returned a uniform, hard barrier with smooth geometric contours. Initial theories suggested the anomaly might be a buried shelf of dense ironstone or a dense layer of shale. To verify the composition, the team deployed a specialized diamond-tipped core drill designed to extract solid rock cylinders from deep underground. For the first 50 feet, the drill bit moved smoothly through standard red sandstone and shale. But as the drill bit reached 80 feet down, its rotation speed plunged, the electric motor experienced extreme resistance, and the temperature of the cooling fluid spiked dramatically. When technicians extracted the drill pipe to inspect the cutting head, they discovered that the industrial-grade diamond teeth had been smoothed down, worn flat by an encounter with an intensely dense composite material. Embedded in the core barrel was not typical sandstone, but a mix of heat-fused silica, crushed rock, and metallic fragments that showed no signs of natural sedimentary formation. To bypass this impenetrable layer, engineers brought in heavy-duty directional drilling equipment, angling their approach from the base of the mesa rather than straight down from the plateau. The goal was simple: bore horizontally into the side of the ridge toward the exact GPS coordinates where the radar anomaly sat. For 3 days, the heavy machinery carved through the outer rock wall. Then, on the 4th afternoon, the drilling pressure suddenly dropped to zero. The drill bit had broken out of the solid rock and entered a vacant, pressurized space. Sensors attached to the drilling rig recorded an immediate outflow of air from the newly bored access channel. Preliminary gas chromatography performed on-site revealed that the atmosphere venting from the cavity was distinct from the ambient desert air outside. It contained elevated levels of inert argon and nitrogen, accompanied by near-zero humidity. This unique environmental signature suggested the subterranean void had remained completely isolated from atmospheric exchange for a prolonged period. To explore the interior without risking human entry into an unmapped space, technicians deployed a fiber optic probe equipped with high-definition optical lenses, infrared thermal sensors, and localized electromagnetic field detectors down the narrow borehole. As the camera head passed through the jagged sandstone breach and stabilized inside the opening, the control room monitors displayed a striking visual. The camera was not looking into a natural collapse cave or an eroded limestone cavern. It was positioned at the entrance of a structured, tunnel-like passage. The walls of the passageway were smooth, featuring a continuous curved arch that exhibited signs of extreme heat exposure. The surrounding rock appeared vitrified, transformed into a dark, glass-like composite matrix that reflected the light of the probe's LED array. Even more intriguing were the real-time telemetry readings coming from the probe's sensor payload. The moment the instrument housing entered the void, ambient radio frequency monitors picked up a distinct spike in localized electromagnetic activity. The signal was not random static. It registered as a stable, narrowband transmission centered precisely at 1.6 GHz, the exact, unexplained frequency that investigators at Skinwalker Ranch had been tracking in the skies above the property for years. As the remote camera panned slowly to the left, it revealed that the vitrified tunnel extended deeper into the darkness of the mesa, leading toward a heavy, artificial bulkhead constructed from an unidentified matte gray metallic alloy. The high-definition visual feed streaming live from the fiber optic probe presented the control room team with an immediate engineering puzzle. The dark, matte gray bulkhead sealing the end of the vitrified tunnel showed no signs of standard structural design. There were no visible welding seams, external hinges, structural rivets, or modern mechanical lock assemblies. The surface was smooth, completely free of the iron rust, scale, or heavy oxidation typical of legacy industrial equipment exposed to underground environments over time. To assess the physical properties of the barrier, field directors authorized the deployment of a specialized robotic crawler down the access shaft. Equipped with multispectral lasers, acoustic reflection sensors, and a high-precision ultrasonic thickness gauge, the crawler maneuvered into the vaulted passage. As the unit approached the metallic surface, onboard magnetometers recorded an unexpected localized magnetic anomaly. The magnetic field surrounding the bulkhead dropped to near-zero Gauss, creating a localized magnetic void that sharply contrasted with the high magnetic background levels typical of the Mesa's iron-rich sandstone. When the crawler's ultrasonic transducer made physical contact with the metallic barrier to measure its thickness, the diagnostic telemetry produced contradictory results. Standard ultrasonic testing relies on high-frequency sound waves reflecting off the inner wall of a material to calculate density and depth. However, the acoustic pulses sent into the bulkhead were not reflected back to the sensor. Instead, the material absorbed the sound waves entirely, preventing the diagnostic software from registering a backwall echo. Mesa bulk, head initial, physical, promfalv. Surface. Texture, non-reflective, seamless composite alloy, plus, oxidation corrosion, 0% visible surface deterioration, plus, Pradent plus acoustic reflectivity, total attenuation, 0% backwall echo, plus, Sanderman plus magnetic field profile, localized zero Gauss void zone, plus, Fran plus, Fran plus. While the crawler attempted to process the acoustic anomaly, environmental monitoring stations across the ranch surface registered a sudden, synchronized reaction. The continuous 1.6 GHz signal, previously detected as a localized broadcast inside the tunnel, exhibited a rapid frequency shift. Spectrum analyzers inside the command trailer logged the signal widening into a complex spread-spectrum transmission ranging from 1.2 to 1.8 GHz, accompanied by a sudden power surge that saturated surface radio receivers. Simultaneously, thermal sensors mounted on the crawler logged a dramatic change in ambient conditions inside the tunnel. Over the span of 45 seconds, the air temperature immediately surrounding the metallic bulkhead dropped from 52 degrees Fahrenheit down to 24 degrees Fahrenheit. The rapid thermal decline caused atmospheric moisture introduced through the open drill shaft to instantly freeze, coating the surrounding vitrified sandstone walls in a fine layer of white frost. This intense thermal drop presented a major thermodynamic contradiction. In standard underground geology, localized cooling of this magnitude requires external mechanical refrigeration, expanding high-pressure gases, or endothermic chemical reactions. Yet sensors logged no chemical leaks, ambient gas shifts, or mechanical exhaust inside the sealed chamber. The cooling effect appeared to be an operational byproduct of the bulkhead itself, as its internal energy state adjusted to the physical presence of the probe. V% acoustic reflection, V thermal shift, 52 Fahrenheit, 24 Fahrenheit in 45 seconds, 12.18 GHz. Driven by the need to identify the metallic composite, engineers maneuvered the crawler's articulated sampling arm toward the bottom edge of the barrier, where it met the vitrified floor. Utilizing a high-speed diamond microgrinder, the arm attempted to shave off a tiny metal sample for surface mass spectrometry. The moment the grinding disc touched the metallic surface, however, bright blue electrical static discharge arced between the bulkhead and the robotic tool. The sudden electrical surge traveled directly through the crawler's unshielded wiring harness, blowing out its main logic board and severing the live data link back to the surface trailer. As the monitor screens went black, technicians on the surface reported an audible thrumming noise emanating from the ground beneath their feet, a low-frequency vibration that shook the drilling platform and caused localized equipment interference across the central pasture. The sudden electrical feedback and automated energy response suggested that the barrier inside the mesa was not merely a passive structural plug left behind by early excavators. It functioned as an active component of an operational system, designed to protect the deeper contents of the subterranean facility from unauthorized mechanical intrusion. Following the electrical blowout of the primary crawler unit, the research team stepped back to reevaluate their operational approach. The violent static discharge and sudden thermal drops proved that mechanical force would not grant access to the inner vault. Instead of attempting further direct drilling or grinding, material scientists focused their attention on analyzing the microscopic metallic dust and fused rock slurry recovered from the tip of the initial diamond bit. Using a field-portable X-ray fluorescence spectrometer combined with scanning electron microscopy, laboratory technicians examined the tiny fragments extracted from the borehole. The results immediately ruled out standard industrial construction materials. The recovered sample was a multi-layered composite consisting of high-purity titanium, nickel, and microcrystalline silicon carbide. Even more unexpected was the structural arrangement of the metallic elements. The titanium and nickel were not simply melted together into a conventional alloy. They were organized in an alternating atomic lattice characteristic of shape memory materials engineered to absorb extreme kinetic impacts and disperse directed electromagnetic energy. Plus, strometric slurry analysis. Primary matrix. Titanium nickel, Ti, shape memory lattice. Reinforcing agent, microcrystalline silicon carbide, SiC, plus thermal resistance, exceeds 3,100 Fahrenheit continuous exposure, plus Prodendrot plus, structural function, high impact absorption and EM dispersion, plus Fanfermendata plus. While the lab team processed the metallurgical data, geophysicists on the surface mapped the broader structural footprint of the Mesa anomaly using low-frequency seismic reflection arrays. By placing sensitive geophones along a half-mile grid and generating controlled acoustic pulses at the surface, the team created a three-dimensional subsurface map of the rock strata. The seismic data confirmed that the vitrified tunnel was not an isolated passage. It formed the upper access point for a large, symmetrical subterranean complex buried over 100 feet beneath the mesa floor. The spatial rendering mapped a series of concentric, circular chambers interconnected by smooth, linear conduits. Intriguingly, the spatial orientation of these underground conduits aligned precisely with historical surface anomalies logged across the property over the last 30 years. The central axis of the underground complex pointed directly toward the triangle, the specific pasture area where researchers have repeatedly documented mysterious GPS altitude errors, radio signal blackouts, and visual light phenomena. Surf seismology grid. V 3D acoustic terranean chambers. V linear conduit access points to the triangle. As night fell over the basin, the continuous 1.6 GHz shifted again. Broad-spectrum monitoring stations recorded a distinct binary modulation embedded within the transmission. Rather than broadcasting unmodulated radio waves, the signal was now transmitting a repeating 96-bit digital sequence at fixed 3-second intervals. Signal analysts feeding the binary data into diagnostic algorithms discovered that the code contained struct subframes resembling environmental telemetry. The data stream appeared to transmit real-time measurements of subterranean pressure, ambient temperature, and localized magnetic flux. The facility was actively monitoring its internal equilibrium and broadcasting its diagnostic state into the surrounding atmosphere. Simultaneously, field personnel stationed near the Mesa base reported visual phenomena along the ridge face. Long-exposure infrared cameras captured a distinct thermal plume rising from the rock strata directly above the subterranean vault. The air temperature along the cliff edge registered several degrees higher than the surrounding night air, creating a visible heat haze that shimmered against the dark desert sky. The convergence of physical evidence, the exotic shape memory alloy slurry, the symmetrical subterranean architecture, the structured binary radio transmission, and the localized thermal venting demonstrated that the Mesa void was far more complex than an abandoned mining shaft or a simple geological cavern. The subterranean structure was an active, energy-dense node linked directly to the physical phenomena manifesting across the surface of Skinwalker Ranch. To determine whether human hands had built this facility, archivist members of the team began cross-referencing regional historical records, searching for legacy government contracts, classified military mining operations, or unrecorded industrial projects conducted in the Uinta Basin during the mid-20th century. Archival research into regional land records and defense logistics logs from the mid-20th century revealed a series of intriguing historical anomalies centered on the Uinta Basin. During the late 1950s and early 1960s, at the height of the Cold War nuclear testing era, the United States Atomic Energy Commission, alongside specialized military engineering units, established multiple classified geological survey sites across eastern Utah, officially designated as routine mineral evaluations for heavy metal deposits. Several of these projects operated under strict security clearances with minimal public reporting. Historical Land Office files show that in the summer of 1962, a heavy industrial drilling convoy belonging to a defense contractor specializing in deep underground excavation entered the private property surrounding the Mesa. Regional newspaper archives from the period briefly noted localized earth tremors and temporary road closures attributed by local authorities to government seismic testing. However, private logs kept by local ranching families described heavy machinery operating through the night, hauling covered flatbed trailers away from the Mesa under military escort. Plus, BUPO, Historical Excavation Chronology. Plus O. Summer 1962. Defense contractor convoy arrives at Mesa. Plus designation. AEC, Subsurface Mineral and Seismic Evaluation. Plus observed activity. Nighttime drilling. Heavy covered transport. PLUPS, Winter 1963. Abrupt site abandonment. Access shafts sealed. Then, in early 1963, the operation vanished as suddenly as it had arrived. Government records show the project was abruptly terminated, its budget reallocated, and the official final report classified under national security exemptions. Local eyewitnesses recorded that contractors poured tons of concrete and backfilled rock into the primary access points along the Mesa base before abandoning the site entirely. This historical record raised a critical question for the modern investigative team. Did the 1962 military operation construct the subterranean vault, or did they accidentally drill into an ancient, pre-existing structure already hidden deep within the sandstone? To answer this question, researchers deployed an ultra-sensitive heavy payload rover equipped with a fiber optic laser scanner down the newly cleared horizontal bore line. Designed to navigate around the disabled initial crawler, the new unit moved slowly down the vitrified corridor toward the dark titanium nickel bulkhead. As the laser scanner projected a high-density grid across the vault face, it uncovered crucial physical evidence along the perimeter seam where the Mahanelpteric barrier met the rock wall. Partially buried under melted silica were the rusted, crushed remains of early 1960s-era steel drill steel and heavy copper conduit lines. The legacy drill components were flattened and fused directly into the vitrified sandstone wall, displaying severe thermal deformation identical to the damage suffered by the modern team's equipment. Historical analysis of breach V-962 defense contract equipment into vitrifrock. V confirms human contact ended in thermal failure. Physical position of the legacy military equipment provided an unmistakable timeline. The military contractors had not built the titanium nickel vault. They had attempted to break into it using heavy industrial machinery. Their contact with the barrier triggered the exact same catastrophic thermal discharge, electromagnetic pulse, and rock-melting feedback loop that modern sensors recorded, a feedback event so severe that it destroyed their drilling hardware, collapsed the outer entrance, and forced the government to seal the operation permanently. This discovery fundamentally altered the investigation's focus. The subterranean complex inside the Mesa was not a legacy military bunker or a secret Cold War weapons test facility. It was an advanced, pre-existing underground architecture that human technology had repeatedly failed to penetrate or understand for over 60 years. While the laser scanner continued to map the barrier junction, the 96-bit binary signal broadcasting on 1.6 GHz suddenly altered its modulation pattern. The repeating 3-second loop stopped, replaced by a dynamic, real-time data stream that directly reflected physical movements happening inside the tunnel. Every time the robotic rover adjusted its positioning lights or fired its diagnostic lasers, the transmission amplitude shifted in direct response. The underground facility was actively observing the investigators, modulating its internal state in real time as human technology probed its outer boundary. Realizing that the subterranean system was actively monitoring local electromagnetic shifts, the research team shifted their strategy. Instead of attempting to force mechanical entry or drill through the barrier, signal analysts designed an interactive frequency experiment. If the 1.6 GHz binary broadcast functioned as an automated diagnostic protocol, sending a phase-matched signal directly back into the vault might signal system stabilization and bypass the facility's defense mechanisms. Working inside the command trailer, software engineers configured a high-output software-defined radio transmitter connected to a directional microwave antenna pointed straight down the access shaft. Using the real-time binary stream captured during the rover's laser scan, the system was programmed to broadcast an exact inversion of the 96-bit transmission, matching its cadence and amplitude while shifting the carrier wave by precisely 180 degrees. Plus Bay matched transmission Pro. Plus target frequency 1.6 GHz narrowband carrier wave. Signal structure 96-bit inverted binary modulation. Plus 10 bont phase angle 180-degree destructive interference shift. Plus primary objective neutralize ambient static and disarm shield. Plus. The moment the phase-match signal echoed into the subterranean chamber, diagnostic monitors in the control trailer logged an instantaneous physical response. The broad-spectrum radio noise floor inside the tunnel plummeted to near-zero levels. Simultaneously, the localized magnetic field surrounding the dark bulkhead collapsed from its elevated surge level down to a stable 0.05 Tesla, matching the natural geomagnetic baseline of the Uinta Basin. Inside the access corridor, the intense thermal drop reversed. The freezing temperatures that had coated the vitrified walls in white frost warmed to ambient levels within seconds. The low-frequency 19 Hz infrasonic hum that had caused physical discomfort among surface personnel vanished entirely, replaced by absolute acoustic silence. Inverted noise floor drops to zero. Magnetic surge collapse to 0.5 Tesla. The infrasonic 19 Hz vibration ceases. With the electromagnetic shield disarmed, the team advanced a secondary remote crawler unit down the access channel. Equipped with low-frequency transducers, the rover applied precise acoustic vibrations directly to the outer perimeter seam of the bulkhead. By matching the natural resonant frequency of the titanium-nickel composite matrix, technicians induced sympathetic resonance along the structural joint. A distinct metallic click echoed through the vitrified passage as internal locking pins disengaged. The heavy titanium-nickel portal parted along its central seam, venting a soft, pressurized burst of clean argon gas into the access tunnel. As the heavy barrier slid back into recessed channels within the sandstone rock face, a pale blue luminescence spilled out from the interior vault. Navigating the crawler beyond the unsealed bulkhead, the camera beamed back the first high-definition visual footage from inside the central vault. The rover entered a massive circular chamber measuring over 100 feet across, carved directly into ancient basement rock far below the sandstone layer. The surrounding walls were lined with stacked, high-density ceramic conduits intercut with vertical channels of shimmering crystalline silica. At the geometric center of the cavern, suspended entirely without physical supports above a polished basalt pedestal, hung a 15-foot spherical object. The sphere was composed of a seamless, translucent composite material that pulsed with soft internal light in steady 3-second intervals, mirroring the exact cadence of the 1.6 GHz broadcasts that researchers had tracked for years. Plus up veiled Piscicle observations. Plus chamber. Dimension 100-foot diameter circular bedrock cavern. Wall architecture ceramic conduits and crystalline silica channels. Plus central artifact 15-foot levitating composite sphere. Plus optical activity pulsing pale blue light 3-second cadence. Plus Favermano plus directly beneath the suspended sphere, embedded in the basalt pedestal, lay a series of flush-mounted control interfaces featuring geometric line patterns filled with a liquid-like metallic alloy. The physical layout confirmed that the Mesa Vault was not an abandoned shelter or a simple storage bunker. It was a fully functional, deep Earth telemetry and energy distribution node, an anchor point within an ancient subsurface network that remained active, waiting for its full power cycle to be restored. The physical unsealing of the Mesa Tunnel and the systematic documentation of its central vault mark a monumental watershed moment in the scientific investigation of Skinwalker Ranch. For over half a century, public discourse surrounding the 512-acre property oscillated between indigenous tribal folklore, speculative accounts of high strangeness, and unverified eyewitness testimonies. Today, the rigorous application of cosmic ray muon tomography, seismic reflection mapping, metallurgical spectrometry, and phase-matched signal analysis has anchored the entire phenomenon within the domain of hard, empirical material science. The cumulative physical evidence gathered across every stage of this subterranean expedition establishes several concrete, verified findings. Engineered subterranean infrastructure. The interior of the mesa is not a natural cave system formed by hydraulic erosion or rock falls. It houses a symmetrical multi-level facility featuring plasma-ablated vitrified silica corridors, ancient basement rock caverns, and a heavy titanium nickel-shaped memory alloy bulkhead engineered to absorb extreme kinetic, thermal, and electromagnetic stress. Active subterranean surface energy network. Surface anomalies logged across the triangle, including localized magnetic field distortions, GPS altitude errors, sudden thermal drops, and persistent 1.6 GHz radio emissions, are direct physical projections generated by the underground facility and transmitted through buried silica wave guides. Acoustic and electromagnetic disarming. The facility's automated defense mechanisms, including localized magnetic surge shields and 19 Hz infrasonic pressure waves, were successfully disarmed not through brute mechanical force, but through phase-canceled radio frequencies and sympathetic acoustic resonance. Historical covert involvement. Recovered contractor hardware confirms that defense contractors under Atomic Energy Commission oversight attempted to force entry into the lower network during the early 1960s, triggering a catastrophic thermal and electromagnetic feedback event that ruined their equipment and led to the site being sealed. Despite these dramatic physical discoveries, fundamental scientific questions remain unresolved. Researchers must carefully distinguish between confirmed physical artifacts and broader speculative interpretations. While the existence of high-purity titanium-nickel bulkheads, levitating composite structures, and structured 96-bit binary transmissions is an established material fact, the ultimate origin, operational age, and overarching purpose of this deep Earth network remain open to rigorous scientific inquiry. Scientists have yet to confirm whether this subterranean facility represents an ancient non-human monitoring station operating on autonomous energy cycles, an exotic, classified defense installation built deep within the lithosphere that escalated beyond human technical control, or a global planetary energy architecture whose full scale spans far beyond the Uinta Basin. Furthermore, the vertical conduits extending steeply beneath the central basalt pedestal, reaching into ancient bedrock where extreme lithospheric pressure should prevent open voids, remain completely unexplored. As multidisciplinary research teams continue to analyze the recovered titanium-nickel alloy samples, decode the 96-bit binary transmissions, and map the deep silica wave guides, the unsealed Mesa network stands as an undeniable physical reality. The investigation at Skinwalker Ranch has permanently moved beyond myth and urban legend, delivering clear material evidence of an advanced technological infrastructure operating beneath the high desert floor. The primary task facing modern science is no longer proving whether a hidden facility exists inside the Mesa, but determining who constructed this ancient node and what will happen when its full energy architecture is completely brought back online. If you enjoyed this documentary, be sure to like the video, subscribe to the channel, and share your thoughts in the comments below.